Good morning, everyone. A very good morning. Shall we begin the session? Yes, today's topic is relational databases. In the last class, we have finished about the languages, yes, data dictionary, metadata, everything we have finished in the last class. That is just the introduction of the database. So shall we begin with the next part or should... Okay, so wait for others. Okay, so wait for 3 minutes more. Yes, relational database is something that works on the relation. That means a table in which every table has some relationship with each other. That may be a one-to-one relationship, one-to-many, many-to-many, or anything. All right. So wait for 2 minutes more. Let's begin with the session. Okay. So what is the relational database? That is based on the relational model that uses a collection of the tables. That means when we combine multiple tables to represent both the data and the relationship among those data, that is known as a relational database. And it also includes the DML and DDL that we have studied in the last class. Now, can anyone tell me what is the difference between the DML and the DDL? Okay, Larry, very good. DML stands for data manipulation language and DDL stands for data definition language. All right. Any other point? Anyone else? Yes, DML works on the internal parts, right? And DDL works on the structure of the table. Very good. Can you name any of the command that is available in the DML as well as the DDL? Yes, insert, update, delete. Okay. What about the DDL commands? This is altered. Okay. So this also represents, so this is also available in the relational database, that is a DDL and the DML. Now, first concept is a table. What is a table? That is a collection of rows and the column that has a unique name. And this, yes, table also represents a very simple relationship among them that comprises two tables. One shows the university instructors and other shows the details of the various instructors. Now, the first table, as per our example, that is instructor table, shows, for example, that an instructor named Constraint with the ID 5 times 2 is a member of the physics department, has an annual salary of the 95,000. In the same way, there is a second table over here that represents, or that the name of the table is department, that shows the biology department that is located in the Watson building has a budget of the 90,000. So there are multiple budgets, there are multiple online teaching, there are multiple departments, there are multiple instructors. So in this concept, there is a need for the relation that is known as a relational model, that is known as the table. Yes, another name of the table is relation in terms of the relational model. This is one of the best example of the record-based model, and they are so called name because the database is structured in a fixed format records of the several type. Each table contains records of a particular type, and each record type defines a fixed number of the attributes, fields, and the sector. Yes, and the columns of the table correspond to the attributes of the record type. That means, yeah, record is any row, anything about, yeah, full-fledged information of a table. For example, listen. For example, suppose I created a table student that includes a name, age, roll number, marks. For example, 4 fields are available. And if I have to fill the name of one person, then age, then marks, then roll number, that is one record. Yes, another name is tuple also, yes. Then next record, means any relevant information about the field that is known as the record. And it is not hard to see how many tables may be stored in a file. For example, a special character such as a comma may be used to delimitate the different attributes of the record. In the same way, another special record character, that is a new line character, may be used to delimitate the records also. And this also hides such low-level implementation details from the database developer and the users. So we are taking the department budget as attribute of the instructor record. This is one of the table that is given, instructor table. ID, name, department name, salary. Yes, these are the records of this. And then there's a department table, department name, building, budget. Now, what is the relationship between these? There's a department name over here. There's a department name over here. Then next is a DML. So SQL query language is non-procedure, and whatever the query we take, that means we take several tables and always returns a single value. Here's an example how the SQL query finds the names of all the instructors in the history department. Select instructor name from instructor where the instructor department name equals to history. And this query specifies that those rows from the table instructor where the department name is history that must be retrieved and the name attribute of these rows must be displayed. More specifically, the result of executing this query is a table with a single column labeled as a name. Why? Because we are taking only the name from the instructor table. Yes, select is used for fetching the table, fetching the column from the table. From is the table name. Where is the condition? So we're taking out the name field. That means all the names that is used from the instructor table. This is the instructor table. Condition is where the instructor dot department name. That means where the department name equals to first history. This is the history. Where the history, this is available over here. 1, then 2. Only 2 records are available with the name, that is EL set and Califrey. No. Salary is not available. Department name is not available. Only one field is available, that is a name. Yes, we can. Just a minute. Just a minute. It is available. Yes. So in the same way, we can also fetch the queries to involve the information from more than one table. For example, the following query find the instructor ID, department name of all the instructor that is associated with the department with the budget greater than 95,000. So we have to write a query, select instructor ID or instructor.id. That means we are taking the ID from the instructor, department name from the department. Yes, we are taking the two tables, instructor and the department, where the instructor.department name equals to department.department name and department budget is greater than 95,000. And if the above query were run on the tables in figure this one, the system would find there are two departments in the budget of greater than 95,000. That is the computer science and the finance, and there are 5 instructors in these departments. Therefore, the result of the table with the 2 columns, ID department name, and 5 rows, 1 2 2 1, 4 5 5 6 5 computer science, then 1 0 1 0 1, because these contains a budget greater than 95,000. Now, any doubt anyone over here? Okay, take 2 minutes. Now, the next part is a DDL. So we are finished with the DML and next is TDL. SQL also provides a rich TDL that allows ones to define the table's integrity constraint assertions. For example, when we talk about the creating a table, so this is creating a table department, there's a department name, then there is a data type. For example, there is a data type char, then building, data type is char, then budget, and data type is numeric with the 12 digit with the 2 decimal point. And the execution of the above DDL statement create the department number or table with the 3 columns, department name, building, budget, each of which has a specific data type associated with it. And we'll discuss the data types in more detail in chapter number 3. And the DDL also update the data dictionary which contains some metadata, that is the data about the data. Then database access from the application programs either using the C, C++, Java, and application program must interact with the database in this fashion, in this manner. Example in a university system are the program that allows the student to register for the courses, generate the class roster, calculate the student GPA, generate the payroll checks. To access the database, the DML statements need to be executed from the host language. And there are 2 ways to do it: by providing an application program interface that can be used to send the DML DDL statement to the database and also retrieves the data. And ODBC, that is Open Database Connectivity, also stands for the use with the C language, that is commonly used application program interface standard. And JDBC standard provides the corresponding features also, that is provided with the DML calls, DML precompiler, DML statements. So finish with the relational database with the DDL, DML. Next part is the database design. So database systems are designed to manage the large bodies of the information. These large bodies of information do not exist in the isolation, but they are the part of the operation of some enterprise whose end products are available, whose end products are maybe the information from the database or maybe from other sources, device, service for which the database plays an important role or the supporting role. So database design mainly consists or mainly involves the design of the database schemas and the design of a complete database application environment that meets the need of the enterprise. Being models, being requires attention to the broader set of the issues, and in this text we focus initially on the writing of the databases, queries, and the result of the database schemas. In this we are using the application design. So there's a design process. High-level data model provides the database designer with the conceptual framework in which to specify the data requirements of the database users and how the database will be structured to fulfill the requirements. And the initial phase of the database design then is to characterize fully the data needs for the prospective database users that will be used with the domain experts and the users to carry out this task. And the outcome of this phase is the specification of the user's requirements. Next, the designer also chooses a data model by applying the concept of the chosen data model, translate these requirements into the conceptual schema that is developed at this one that provides a detailed overview of the enterprise. And this review the schema to confirm that all the data requirements are indeed satisfied and not in conflict with one another, to examine the design to remove any redundant features. And the focus at this point is on describing the data and their interrelationship rather than specifying the physical storage details. That is how to group these details, or what is the main part, or what part is basically a business decision that is not discussed in this text. And the fully developed conceptual schema also indicates the functional requirement of the enterprise. And in the specification of the functional requirements, user also describes the kind of the operations that will be performed on the data. Example includes modifying or updating the data, searching, retrieving the specific data, and deleting the data. And at this list of the conceptual design, the designer can review the schema to ensure its functional requirements, functional needs. That is included in the logical design phase, physical design phase. Next is the database design for a university organization. This is one of the example. So initial specification of the user requirement may be one of the case that is available over here, may be used. That is the analysis of the phase. And the description that arises from this design phase serves as a database users which identifying the particular building. So to illustrate the design concept, let us examine how the database for a university could be designed. And the initial specification of the user requirements may be based on the interviews with the database users, designer own analysis of the organization, and the description arises from the design phase serves as a basis for specifying the conceptual structure of the database. And these are the few characteristics of the university that is organized into the departments, and each department is identifying by the unique name, that is a department name that is located on a particular building, has had a budget, and each department has its own value that is defined over here. Now the university is organized into the departments. Each department is organized with a unique name, that is a department name that is located in a particular building and has a budget. And each department has a list of the courses it offers. Each course has attributes like course ID, title, department name, credits, and may also have associated the prerequisite, and instructors are identified by their unique ID. Each instructor has a name, associated department, that is the department name, and the salary. Then students are also identified by their unique ID. Each student has a name, each student has associated major department, that is the department name, and a total credit with the hours the student entered or earned so far. And the university also maintains a list of the classrooms specifying the name of the building, room number, and the room capacity. This database also shows with the list of the classes, section taught, and each section is identified by the course ID, section ID, year, semester, and then has associated with the semester, year, building, room number, time slot ID. when the class meets. The department has a list of the methods, list of the attributes, list of the teaching assignments specifying for each instructor the section the instructor is teaching out. And the university has a list of all the students' course registrations specifying for each student the courses and the associated sections that the student has taken out. And when you talk about the real university database, that must be more complex than the preceding design. The next part is the ER model, that is the entity relationship model. This uses a collection of the basic concepts known as entities, relationship among these objects. And entity is a thing or the object in the real world that is differentiable from the other objects also. For example, each person is an entity and the bank account can be considered as the entities. So any real-time entity or any real-time consideration is known as the entity, and that are described in the database by the set of the attributes. For example, a person has attributes like the name, uh, that is the last name, address, department, whatever. For example, the attributes department name, building, budget may be described as a one department in a university, and they also form the attributes of the department entity set. Similarly, attributes ID, name, salary may also describe an instructor entity. And the extra attribute ID is used to identify an extra instructor uniquely, and unique instructor identifier must be assigned to each instructor. In the United States, many organizations also uses the social security number of a person, that is SSN number, that is defined in over here as a unique identifier. And the relationship is an association among the various entities. That is how these entities are related with each other. For example, if I talk about the teacher and the student, what is the relation? Teacher teaches the student. So teaches is a relation. Teacher and the student are the entities, we can say. So a member relationship also associates an instructor with a department, and the set of all the entities of the same type and the set of all the relationship of the same types are terms as the entity set, relational set respectively. And the overall logical design structure schema of the database can be expressed graphically by an entity relationship diagram. And there are multiple ways in which to draw these diagrams, and one of the most popular is to use UML, that is Unified Modeling Language, which is based on UML. ER diagram is as follows. So these are the instructors, department, ID, name, salary, department name, building, budget. And entity sets are represented by a rectangular box with the entity set name in the header and the attributes listed below it. And the relationship sets are also represented by a diamond connecting a pair of the related entity set, and the name of the relationship is also placed inside the diamond. And as an example, consider the part of the university database consisting of the instructors and the department with which they are associated, that is defined with the two entity sets, instructor and the department with attributes. And the diagram also shows an relationship member among or between the instructor and the department. And one important constraint is mapping constraint or mapping cardinality, which expresses the number of the entities to which another entity can be associated via the relationship set. For example, if each instructor must be associated with only a single department, the ER model can express to such constraints. And the ER model is widely used in the database design, in the database concepts, in the ER models. The next one is a normalization to reduce the redundant data, to reduce the duplicate data, we use the normalization. So it is one of the way to simplify the database, to simplify the schema that are in appropriate normal form. And to determine whether a relationship schema is one of the desirable normal forms, we need additional information about the real world enterprise that we are modeling with the database. And the most common approach is to use functional dependencies. So to understand the need for the normalization, let us look out the bad database design. And among the undesirable properties that a bad design may have, the repetition of the information, inability to represent the certain information. Such can be modified with the database design with the instructor and the departments. That is used with the department name, that is used with the building, that is used with the budget. One solution to this problem is to introduce a null values that indicate that the value does not exist. That means there is a blank value. And the unknown value may be either missing, the values does exist, but we do not have the information, or not known. Next one is the data storage and the query. So this is used to partition into module that deals with each of the responsibilities of the overall design. And the functional components of the database design can be broadly divided into the storage manager and the query processor components that typically requires a large amount of the storage space, that is range in the size from the 100 of the gigabytes from the large database, terabytes, that is approximately 1000 megabytes, terabyte, that cannot store this much of the information. The next one is the storage manager, that is a component of the database design that provides the interface between the low-level data stored in the database and the application programs and queries submitted to the system. And the storage manager is responsible for the interaction with the file manager, and the raw data are stored on the disk using the file system provided by the operating system. And the storage manager translates the various DML statements into low-level file system commands. This is the storage manager. And the storage manager is responsible for storing, retrieving, and updating the data in the database. That must include authorization and the integrity manager, transaction manager, file manager that manage each and every file that is available on the disk. Yes, that is available on the whatever the files, whatever the space on the disk storage. Then buffer management. And this also defines various structure as a part of the physical system implementation. So first is the data files, then data dictionary, then indices. Next part is a query processor. This is a lengthy topic, so we will discuss this topic within the next class. Yeah, this includes an interpreter compiler. Okay, so we will continue with the transaction management. Okay. So any doubts, anyone in the today's class? So if you have any doubt, then please clear the doubt.